Hello again. So in these examples, we're looking at algebraically thinking about the inverse. So again, like I said in the graphical one, in inverse, we're inverting the points. So on the original, my xy becomes the yx in the inverse. So that's going to help us down here. So on my original function, I have the point 0, -1, and -1, 2. So f inverse of -1. Let's think about what we're doing here. This means we're taking, I'm going to make a little table over here to help me show this. So x, f of x. So if we put in 0, we get out -1. We put in -1, we get out 2. Well, if I think about an x and the f inverse of x, I take these points and I flip them. So -1, I get out 0. 2, I get out -1. So now, f inverse of x, when I put in the -1, I get out the 0. I can also think about this is the y value on the original function, and it gives me the x. So f inverse of -1 is equal to 0. F inverse of f of 0. Well, f of 0 is -1, so this is the same as f inverse of -1, and I get out the 0. But of course we knew that because if they're inverses, I know that by definition, f inverse of f of x is equal to x. So in this case, I get back the x. Same idea here. This is also true for an inverse. F of f inverse of x is equal to x. So I don't even need to do any calculations. That's just going to be 2. All right, let's look at this one here. So I've got f of x is 2x cubed minus 1. Let's look at our graph. F of x is 2x cubed minus 1. G of x, we've got the cube root. So I don't have a cube root here, so I'm going to raise it to the 1/3 power. And we had x plus 1 divided by 2. So x plus 1 divided by 2. I want to take this whole thing and I want to cube root it, so I'm going to raise it to the 1/3 power. So there's my cube root. Okay, it certainly looks to me like they're inverses. This part reflects over, so it will come down. My point -1, 0 should become 0, -1. My points where they intersect cross. So 1, 1 stays 1, 1. Let's test it this way also. F of g of x does make the line y equals x. G of f of x also makes the line y equals x. So they're definitely inverses. Here is what I need to show algebraically to test it. So sketch a graph, yes, and now show it algebraically. F of g of x, so cube root x plus 1 over 2, that's going to be 2 cube root x plus 1 over 2 cubed minus 1. Cube root and cube, of course, cancel. So I'm going to have 2 over x plus 1 over 2 minus 1. Of course, that's going to give me x. Same thing, g of 2x cubed minus 1. I'm going to get cube root of 2x cubed minus 1 plus 1 divide by 2. So here's my plus 1. So, of course, this also gives me x. So they are inverses.